Let's begin the first section, Q1, talking about quadrilaterals. So we have a note page here. We're going to record what we know about each of the different kinds of quadrilaterals. So first of all, a quadrilateral is a polygon with 4 sides. Poly means many, and a polygon is a many-sided figure. A polygon with 4 sides is a quadrilateral. I can draw a 4-sided figure. A counterexample means something that is not a quadrilateral. So a pentagon or a triangle would be examples of not having a quadrilateral. Okay, what we're going to do is we're going to look at the quadrilateral cards and we're going to sort them out. They're all quadrilaterals on the piece of paper, but we're going to start with trapezoids. So we're going to take out cards from the pile that have exactly 1 pair of parallel sides. So let's look at that page. I'm looking at the figure in A. Card A, the quadrilateral has top and bottom sides parallel. The next card that looks like that is card G. The next card that looks like that is H. And I think there's one more. Look at K. In card K, the parallel sides are not like horizontal anymore, they're on a slant. So on your note paper, list the cards that are trapezoids. So that would be A, G, H, and K. The definition of a trapezoid is a quadrilateral with exactly 1 pair of parallel sides. Go ahead and provide a diagram. The exact way to indicate a trapezoid is to actually put the markings on there for the 1 pair of parallel sides. To show a counterexample of that, you could draw a figure with that pair of parallel sides, but then the other pair also parallel. That would definitely be something that is not a trapezoid. What we're going to do now is we're going to set the cards aside that are trapezoids. So let's do that. I'm going to take out this card, this card, this card, and this card. I also want you to remove cards L and N. Card L is a quadrilateral with no parallel sides, and N is also a quadrilateral with no parallel sides. What we have left of these cards are parallelograms. Let's list out the cards that are parallelograms. If they don't have 1 pair of parallel sides and they don't have no pairs of parallel sides, then these remaining cards have quadrilaterals with exactly both pairs of opposite sides parallel. Now we're going to look at this pile of remaining parallelograms and we're going to pick out the ones that have 4 right angles. So when we do, we'll find the rectangles. Look at card D. That parallelogram has 4 right angles. Card E, that one does also. Card F, and there's one more. Which one is it? What we just did is we took parallelograms and we picked out ones that had the 4 right angles. That is your definition of a rectangle. When I draw the example diagram, I'm going to start with the parallel sides. That tells you it's a parallelogram. And then I really only have to indicate 1 right angle. It is only necessary to show 1 right angle because the rest of the angles will be right angles from a theorem we got earlier, and it was if the lines are parallel, then interior angles on the same side of the transversal are supplementary. So look at this bottom left angle I marked with right angle. That means the bottom right angle is forced to be a right angle because they're supplementary. Now, because the top and bottom are parallel, The top right angle is forced to be a right angle because the right angles are supposed to be supplementary, and then same thing for the top left angle. If you want to draw a counterexample, a parallelogram that does not have right angles. Let's go back to the pile of cards and find the cards that have all sides congruent. Notice on card C, that parallelogram has congruent sides. Notice card E, that one has congruent sides. Card F, and there's one more. Do you see the last one? Card I. So these four are called a rhombus. And the reason they are called a rhombus is because they are a parallelogram with all sides congruent. Here's a parallelogram, and I'll mark all four sides congruent. And a counterexample could be perhaps a parallelogram. I'd like you to note that it is only necessary to mark a quadrilateral equilateral to know it's a rhombus. As soon as the quadrilateral is equilateral, then it also becomes a parallelogram. So it's only necessary to show a quadrilateral is equilateral in order to say it is a rhombus. Next, we're going to find the cards that have the qualities of both a rectangle and a rhombus. So go back to the page of cards. Which of these cards have a parallelogram that is marked as a rectangle, so it has right angles, and it is marked as a rhombus, so it is equilateral? Do you see the two cards? It would be card E and card F. By definition, a square is both a rectangle and a rhombus. If you first mark your example as equilateral, as I have done, that means it is also a parallelogram, as I previously stated. All you need to do from there is indicate a right angle inside that diagram, and that forces it to be a square. So the equilateral marks first, make it a parallelogram, and it's equilateral. Then when you put one right angle in, it forces it to be a rectangle. So a rectangle that's equilateral is a square. I'm simply going to leave out the right angle to create my counterexample to a square. And that's it. We just collected all the definitions for the quadrilaterals we're going to study. Now we're going to combine that information onto a nice foldable piece of paper that we can study with. Here's our foldable piece of paper. It says quadrilaterals down the left side, and notice I have the first column is for definitions. The second column is for properties. We're not learning the properties in this video, we're just learning the definitions. But here are the directions. When you set up this foldable, so if you don't have the paper already, you can just take a piece of paper and draw a solid line down about 2/3 of the way over. And we need, here's one box, here's a second box, third, fourth, and fifth. So separate the right side into 5 boxes. And notice my dotted lines. You're going to cut the boxes along the dotted lines so they fold over to the left. When you cut along here, so I'm going to take my scissors and I'm going to cut along here. Here's my scissors, cutting along here. This is going to fold over, and on the back side I'm going to list the name of each of my quadrilaterals. My first quadrilateral will be trapezoid, so write it nice and big and neat. The next one is parallelogram. The third one is rectangle. Now this isn't on this side. Remember, this is on the back side. You want to write this on the back side of the flap. Then we have rhombus. Then we have square. Okay, this inside space, this is on the other side of the paper, the back side of the paper. Write these words on the back side, and then remember you're going to fold them over when we're done. So you're going to cut along here, cut, 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 and you're going to fold this parallelogram flap over and write the word parallelogram on that side. On the inside here, in the space, we're going to put the definitions for each of the corresponding quadrilaterals. Trapezoid is a quadrilateral with exactly one pair of parallel sides. So that goes there. Next to parallelogram, you're going to write a quadrilateral with both pairs of opposite sides parallel. The definition for rectangle is a parallelogram with 4 right angles. A rhombus is a parallelogram with all sides congruent. You could also write a quadrilateral with all sides congruent if you wanted to. A square is a rectangle and a rhombus. And that's it for today. So you're going to set up your quadrilateral foldable. On this side, under the word definitions, you're going to put the definitions for each of the 5. But on this side, you're going to leave the area under properties blank. Leave the area under properties blank. And then you're going to fold over each flap and put the name of each quadrilateral there. Another thing you could do, you could draw the picture for each of them. Like we put it on the note paper and you could transfer that over. So a trapezoid looks like that. And a parallelogram has its opposite sides parallel. So you want to indicate that. The top is parallel to the bottom and the left is parallel to the right. A rectangle, set it up as a parallelogram and then add 1 right angle and you've got a rectangle. Of course, you know a rhombus is going to be equilateral. I'm going to purposely draw it like this, kind of slant it over, make it equilateral like that. That's perfect. And you don't have to put the parallel lines, the parallel marks there, but you can. And then a square, you're going to need the equilateral marks from rhombus, and then you're going to need a right angle from rectangle. There you go. And then there's other properties that are involved with each of the 5. We'll go over those properties in the next video. For each of the following situations, we're going to decide if the statement must be true, might be true, or cannot be true. If the statement must be true or cannot be true, we need to provide an explanation for that decision. If the statement might be true, we're going to provide an example where the statement is true and where the statement is false, which means a counterexample. Number 1, a rectangle is a parallelogram. If you remember from our card sort, we had the parallelograms already there, and then we looked for the rectangles among the parallelograms. So this one must be true. The reason why is because both pairs of opposite sides are parallel in a rectangle. That means it's a parallelogram. Number 2, a trapezoid is a square. If you remember in the card sort, we removed the trapezoids from the pile before we saw the parallelograms, and a square is a parallelogram. A trapezoid cannot be a square. The explanation would be a trapezoid has exactly 1 pair of opposite sides parallel, but a square has both pairs of opposite sides parallel, which makes it a parallelogram. Number 3, a rectangle is a square. A rectangle is a square if that rectangle has congruent sides, because a square is both a rectangle and a rhombus. If your rectangle does not have congruent sides, then it would not be a square. We're going to say a rectangle might be a square. So we're going to give an example of when that's true and then an example of when that's false. So if the rectangle has all sides congruent, then it is a square. How about we say if a rectangle is equilateral? If a rectangle is not equilateral, then it is not a square. Number 4. A parallelogram is a quadrilateral. This must be true. All of the cards we placed out on the table were all quadrilaterals, and the parallelograms were among them. This must be true, and it's because a parallelogram has 4 sides. And number 5, a rhombus is a rectangle. This might be true. And we did not say that any of the rectangles were a rhombus, and we didn't say any of the rhombus were rectangles. But when a rhombus becomes a rectangle is when it is a square. So we said a square is a rhombus and a rectangle, and we can say then that a rhombus is a rectangle only when the rhombus is also a square. That's going to happen when the rhombus has a right angle. The counterexample would be when a rhombus does not have a right angle.